So this is the play net for our competition this year, and the theme is Cargo Connect. The theme changes from year to year, and each one of these little play kits the students have assembled, and excuse the mess because we are in the middle of a bunch of different side projects, but the quickie one is that they'll take a robot like this, which is called a base unit, and they're going to have it start over here in the corner and then solve some of these little challenge puzzles. So someone might be as simple as having the robot drive over here and slam down on this little thing here, where it kicks that, this guy slides off. It may be as simple as lifting this little lever up to release a piece of cargo. Some of the more trickier ones are where they actually have to bring up, you have to lift apart and have the robot lift it over here and set it on this while avoiding that chicken. And then each one is worth a certain number of points, and then they're going to compete against high schools, or middle schools and high schools from Eugene, Salem, through the Portland area, and then it goes into the competition.
Do all the schools in the competition have the same exact mat? Okay.
So, yeah, we have we've got 3 teams going to the competition. So this is this year's mat. That one over there is slightly different, it's last year's, and then you can see on the wall where they've gotten the different years for each one of them. So Mr. Merle started this program probably about 15 years ago. So Lego Robotics has been a pretty big, important thing in Siuslaw for quite a long time. We're on colors and lines. So the idea here is that your driving base is quite capable now. You guys have attached the little armature to it. You've attached the eyes to it. And now you're going to kind of get some competition stuff. So we're going to start learning how the robot can track itself using the lines on the table. I've also got a little sumo ring that we're going to use, and it's a great starter ring to have it follow it around.
All right, so we're in Mr. Looney's class with Jonah. And Jonah, this looks super rad. Do you want to say a little bit about what you've got going on here?
Yes, thank you.
So that's your robot. What are all those cords for?
All the cords are for each of the different sensors, and I added this one for like emergency stop button.
All right, Aiden, tell me what you're working on.
I'm working on the base model. I'm trying to attach an eye sensor to it so it can see and detect objects.
Okay, I see. And then what's on your computer screen? Is that how you're testing?
It's basically just telling me what to do, how to build it, and then I'm going to code it.
Okay, and what's that little piece right in front of your robot right there? What does that do?
This is one of the claws. I was just trying to build for it so it could lift objects up and down.
Okay. All right, thank you.
This is my tank. These sensors sense when to stop and go. This move. It has the track.
That is so cool.
It's all armored up for sumo wrestling.
Okay, and does it do anything special?
Not really.
Okay.
It's just massive and can just walk over it and pretty much just shove anybody out.
Okay, so we have a tank for sumo wrestling. Is that what we're calling it?
Yeah.
And then will that be battling this style of robot?
I don't know yet.
Okay. All right, so now we're with Jaden. Jaden, let's hear a little bit about your robot.
My robot, well, he has this thing right here for him to see colors. Right here, it's a distance sensor or a distance. Here's the motors, and it's the EV3, a Lego robot.
Okay. All right, Julian, your robot looks amazing. Can you share a little bit about it? What are we looking at here?
This is the third design of the third iteration of a robot. Third design. Originally it was the least stable robot that we could make it before it couldn't become useful at all. Then after that, it became a little bit more stable. That one was very short-lived. And then this one is our latest model.
Okay. Are you adding a propeller to this one? Is that what I see you doing?
Yes.
Okay, and you know, you talked about your third iteration of the design. I've been circulating all these Makerspace to-go kits, primarily for the elementary kiddos. And really, they celebrate the engineering design process, so that's exactly what you all are doing in this classroom. And we know that you have to often go through several different prototypes and revise. until you get to a final product. So this looks so fabulous. Thank you so much for sharing. Now we are with Mako. And Mako, do you want to share a little bit about your robot and what you're working on today?
I am building a color cube so our robot can recognize the difference between colors.
So it can recognize the difference between color. That's super rad.
So that it knows when to stop and go.
Okay, and do you have, what kind of piece of technology do you have to add to your robot so it can differentiate between color?
The eye sensors.
Okay, the little eye sensors.
The Innovation Lab is my exploratory class. It's kind of a passion project. I have a background in robotics, in design, and just computers in general. So I've got the students learning Tinkercad for 3D printing. So they've been building stuff in Tinkercad, which is a web-based program from Autodesk, which is the big company that produces CAD, Fusion 360 and the CAD programs they design cars with. And then they learn on Tinkercad, and then we can able to print them with the 3D printers over here. Next week, we're going to be starting microelectronics. So we're going to be using Raspberry Pis with breadboards.
Do you want to explain what a Raspberry Pi is for viewers who do not know?
A Raspberry Pi is not an edible food product like it sounds. I'm not sure where they got the name, but they're basically small microcomputers. So they're all in one little units. Here's one right here. And so this entire thing contains everything you need for a keyboard or a computer. You've got an HDMI port, you've got a network port, you've got keyboard and mouse spots, you've got the ability to have sound, and then you can use them to control. You can make a retro video game console, you can control robots, you can have it do a little network utility or thing.
I had a Fulbright friend who did a lot of her work in the Amazon in rural schools without any technology or computers, and she brought mobile libraries via Raspberry Pis. So now those schools actually have access to digital libraries.
That's why I'm a big fan. So they're cost effective, and that means the barrier of entry is really low.
Okay, so we're with Madison in Innovation Lab. And Madison, what are you working on today?
I'm making a, I was out waiting it. I made this music box. I already 3D printed a small one for my 20% project. But I want to make make it bigger and so it can open.
So you're going to 3D print this?
I hope so.
And what program are you using on the Chromebook that's hooked up? Tinkercad, and that's hooked up to these 3D printers right behind me.
No, actually, you load the file on an SD card and load it in the printer.
Okay, cool. Thank you. All right, Arlen, show me what you just created.
All right, so this is like my name inside of an organ thing. Mr. Looney came up with a cool idea. He had to put a line through it so that it would stay together. It's pretty fragile. It's really fun.
Where did you print that at?
Okay.
Or cut it? We don't have a laser cutter in here, do we?
Yeah.
So they designed them, and then I took them all and cut them in the back.
Okay,
Yeah,
so they can design on their Chromebooks, and then you take them and cut them.
It was
okay.
a mix of Tinkercad, which can do a lot of cool stuff, I guess, and then there's another website, I think it was
A vector website.
Vector, yeah.
So Tinkercad plus Vector.
Yeah, plus a laser cutter made this. It's one of my, I like this one.
All right, here's another student, Miles, who's created another really awesome laser cut. That is so cool. So again, you created that within Tinkercad?
Yes, I 3D modeled it and then I got wet printed.
Okay, and then Mr. Looney went and did the laser cutting once you created the file and everything.
Yeah.
Super cool. Thank you. All right, here's Andrew actually designing one of those little State of Oregon nameplates.
So I got my my icon I use for all my accounts. I also have my name, and it's yet to be printed, but it's going to look really cool.
Right now I'm hanging out with Eddie, and Eddie, tell us what you're working on.
I'm gonna make a heart, and I'm gonna put my name in it. That's all I'm gonna do.
Okay, so you're just getting started with the project.
Yeah.
And you are not in the Tinkercad, you're in this, what is that, Vecteezy?
Yeah.
So that's the other program that you all are using, which works on both a desktop computer as well as a Chromebook.
Yeah.
So you do all of your designing within the program and then transfer the files to actually print on the 3D printer or the laser cutter.
Yeah.
Okay, awesome. Thank you.
Just cut it off anyway. These are our 3D printers. Currently we're printing Sally the Viking, and this is Fred the Viking. They're just little figures that we print to keep them busy. The students like them just because they're Viking themed and they get to create something. So in the Innovation Lab, we're looking for more students. Everybody will switch this class out, I think, every 9 weeks, but as far as 6th and 7th graders, if you're interested into technology, you want to learn how to do 3D printing, if you're interested in computers, do sign up. The more the merrier. So
thank you for letting us join both of your classes today. And then one thing I love to remind students is that all of our makerspace kits from the library oftentimes look seemingly simplistic, but we really are celebrating the engineering design process with every single one of those kits, even if it's like problem solving with one sheet of paper. So do you want to say something about the engineering design process and all the classes that you teach? I mean, I've seen your students today and last week working through that process with all of their projects.
Yes, the engineering design process is an important part of our lesson plans and stuff. It's all about finding a problem, researching that problem to try to identify solutions, and then working through different versions of itself. So we do that with something as simple as Tinkercad, when they have to come up with unique solutions to create an object. You might have to mix and match and come up with ways to work around the limitations of the program to get it what you want. And same with 3D design, with graphics design, and we are actually going through the engineering or the creative design process, which is exactly the same thing with just finding the problem or the customer's need and then working through that design iterations until you actually work through the final product. So
yeah, totally college and career readiness skill that all employees need is just problem solving.
Yep,
so
that's what the important part of it is. So.
All right, well, thank you for letting us tour your classes today. It was awesome.